There's a recording studio.
You're in a Catholic school environment, ma'am? Okay. We are recording. Now, let's continue yesterday's lecture. It's a continuation of yesterday's lecture. Let's recall some of the things we did. We were looking at the limit, of course, with the calculator, and we're looking at how to eliminate or extract the limit without the calculator. You're right. So one of the examples we looked at was a very similar example to this one. And in each of these examples, we're going to evaluate the limits. Can someone keep track? This morning I got carried away. I recorded a 50-some minute video and the thing did not let me upload it. So keep track of we're about 12, 13 minutes. That way we could just record several. This example is the limit as x approaches 3 of x squared minus 9 over x minus 3. Let's try it first with the calculator. Let's see what that means. Now, if we're checking, we go to the y equals screen, we put x squared minus 9 over x minus 3, and then we go to table set, we put the ask mode, and then we go to the table. And certainly we want to, let's see. Get rid of any other graph that's there. We go to the table and we go to the ask mode. Now, I always encourage you when you're doing this to look at values. In this case, we're looking at values around 3. Okay? So let's check values in this instance from the left side of 3. Okay, let's check it. Let's look for some values from the left side of 3. The way we were approaching this yesterday was we were choosing, for example, 2.9, right? And then we would say 2.95. Then we said 2.99. Then we went 2.999, and that gave us a very good idea. It gave us a very good idea as to, let me bring it, zoom it up manually. So this would be what? We're guessing this is what? 6. We're guessing this is 6. Okay, now from the left side. Now let's check from the right side. If you want, you could go back in and delete each one of the entries, and from the right side we'd choose a number greater than 3. In this case, we'd go 3.10. Then we go 3.05. Then we go 3.01. And then a bit closer, 3.001. And it seems to be approaching 6 from both sides. That's what it appears to be. Let's allow this to equal 6. Allow this to equal to 6. Now, what we do is, okay, we ask ourselves, the first step in evaluating a limit is substitute, right? That's the first thing we said. Algebraically, we substitute the 3, and what would the substitution give us? 0 over 0. Okay? And what did 0 over 0 mean to us? We're going to have to extract the limit somehow. In this case, it's pretty obvious. The extraction is very obvious. What would we do in this case? We'd factor the numerator 2. What would the numerator factor to? Okay. So the numerator factors to x plus 3, x minus 3, and in the denominator we have an x minus 3, and there we see these terms that disappear, and we're left with the limit as x approaches 3 of x plus 3, and we can see how now substituting the 3 gives us the 6 that we knew was the answer. And that's a very easy case, because in this case all you had to do was factor. Now, not all cases will be factoring. Not all cases will you have 0 over 0. Not all cases, I mean, you just have to approach it in this manner. You have to understand that there are different ways to approach these limit problems. Let me give you another example. Let me give you another example where we have to perhaps do some algebra. Let's see. What would be your initial thought in this calculating this, evaluating this limit? What would be your initial thought while approaching this? If you let's say without the calculator. So but what's the first step in evaluating the limit? Okay, so we make the substitution. So what happens in the substitution? What do we get? 0 over 0. 0 over 0. What does that mean, Buchanan? 0 over 0. You have to extract the limit somehow. And I see some of you, you're punching the calculator. That's fine, but we're going to have to show this, how to extract the limit without the calculator. I need to see that. So let's get to work. What do you think the extraction process is going to require? Sure. Factor the numerator and perhaps factor the denominator. What would the numerator factor to? 2 minus 1. What about the denominator? What would that factor to? Perfect. And there we see the culprit. It's that x minus 1 causing the trouble. That little troublemaker. Okay. X plus 2 divided by x. Now, what would be our step? Substitute 1 plus 2 over 1, which gives us what? 3. Any questions? Did everyone grasp that? Okay, let's go down to the roads of algebra and visit some old friends here. Now, this would be an excellent opportunity to visit our calculator as well and to check what is going on here. Automatically I see, if I substitute, I see that it's going to be 0 plus 100, which is 100, What's the square root of 100? And 10 minus 10? So we have 0 over 0. What does that mean, Salas? 0 over 0. You're going to have to work something out. But before that, let's look at the calculator to see if it could give us some insight as to what the limit is going to be. We're going to have to enter this function in. Okay, so our numerator would be the square root of x squared plus 100. It would be parentheses, square root of x squared plus 100, and then get out of that minus 10. You're going to have to close it now. Divided by parentheses x squared. Close it. And we can actually go to the table, and since this limit's approaching 0, I think it would be a very good idea to check. Remember, I draw the little number line and I tell you, let's check on the left side of 0, and then we could check on the right side of 0 to get a better understanding of what's going on around 0. Let's check to the left of 0. To the left of 0, that would be negative 0.1, let's say. Then negative 0.05. Then negative 0.005. As you can see, each entry is giving us, what is it giving us in each entry? 0.05. Do you see that? So I'm starting to think that this limit is equal to 0.05. 0.05 is actually what? 1/20th? Right? 0.05 is 1/20th. Let's see. Let's check from the right side. What numbers would you choose from the right side? You could choose 0.1, 0.05, 0.001, 0.0001, and in each time the function is returning the value of 0.05. So we're suspecting that this limit equals to, and this is still under investigation, we're suspecting that this limit equals to 0.05, which is, that's 5 cents, so that's 1/20th, right? So 1/20th. Okay, that's what we're suspecting. Now we're going to have to prove that algebraically. Now, how would we show that algebraically? This is where you're going to have to put your algebra hat on. Okay? We're going to have to multiply by this good old friend called the conjugate. Y'all remember the conjugate? If you don't, well, this is a good time to pay attention. The conjugate of the expression in the numerator is the square root of x squared plus 100. Instead of the minus 10, it would be plus 10 over the square root of x squared plus 100 plus 10. That's the conjugate. Now, you get the limit as x approaches 0 of something. Look, you could think of this as a minus b times a plus b. What's the formula of a minus b times a plus b? Algebra 2. What's the formula of a minus b times a plus b? A minus b times a plus b. Isn't that minus b squared? So that would be the first quantity square minus the second quantity square. What's the first quantity squared? Square root of x squared plus 100 squared. That would simply be x squared plus 100 minus the second quantity squared. What's 10 squared? It's 100. all over x squared times the square root of x squared plus 100 plus 10. Well, nice that these two terms would cancel. And look, x squared divided by x squared. What is x squared divided by x squared? 1. We're left with the limit as x goes to 0 of 1 over the square root of x squared plus 100 plus 10. Now, what do we do in this step? Substitute. Excellent. We substitute the 0 for the x. 0 plus 100 is 100. What's the square root of 100? We have 1 over 10 plus 10, which gives us indeed 1/20.